Move over Wi-Fi, step aside Bluetooth. A new player, LoRa, is making waves in the world of connectivity. This signal reaches farther, connects deeper, and is set to change the way we interact with technology. Buckle up as we dive into the fascinating world of long-range, or LoRa for short, and its even more impressive counterpart, LoRaWAN, the long-range wide area network. Have you ever dreamt of a technology that keeps the world connected, even when the usual networks give up? Well, LoRa and LoRaWAN are here to answer that call. Rising from the dust of previous digital wireless data communication technology, these siblings are a power-packed pair, providing reliable connectivity solutions, even in the toughest situations. Picture a world where the conventional networks fail, and yet we stay connected. That's the power of LoRa. In the heart of the 21st century, a new technology was born. This was LoRa, a long-range, low-power wireless platform that is the bedrock of building IoT networks across the globe. Its genesis was in the hands of Cycleo, a tech company nestled in the alpine city of Grenoble, France. But by 2012, the reins had been passed to Semtech, a leading supplier of high-performance analog and mixed-signal semiconductors and advanced algorithms. LoRa quickly found its place in multiple IoT applications, from smart cities to industrial automation. Then, in 2015, the LoRa Alliance was formed, birthing LoRaWAN, a media access control layer protocol for managing communication between LPWAN gateways and end node devices. The technological advancements that followed were nothing short of astounding, propelling LoRa devices into the limelight. This was the dawn of a new era, where long-range connectivity was no longer a pipe dream, but an accessible reality. And so LoRa became a beacon of connectivity in a world increasingly filled with devices. But LoRa wasn't just idling around. As technology progressed, so did LoRaWAN, blossoming from a simple idea to a worldwide phenomenon. It's making waves across the globe, being used in diverse fields, everything from farming and manufacturing to environmental tracking and, yes, even apocalypse prep. Particularly noteworthy is the rollout of LoRaWAN 1, 0.3 and 1.1. These updates some serious upgrades in security and network capacity, enabling more gadgets to connect and chat securely and effectively. This has opened up the playing field for the creation of exciting new devices, all tailored to harness the strengths of LoRaWAN in fresh and inventive ways. Equally extraordinary is the surge in network coverage. Right now, LoRaWAN's reach spans across continents and oceans, offering devices the chance to link up from just about any corner of the globe. LoRaWAN has emerged as a major contender in our interconnected world, but it's got a whole lot more up its sleeve. And with our unyielding drive for progress, who can tell where this adventure will take us next? Here are 8 key features of LoRa and LoRaWAN. Long range. This is arguably the most defining feature of LoRa. It utilizes spread spectrum modulation, enabling its signals to travel much farther than conventional protocols like Wi-Fi or Bluetooth. In rural areas, LoRa can reach ranges of up to 30 miles, while in urban environments, it can still cover several kilometers. This makes it ideal for applications where sensors are deployed over wide distances, such as smart agriculture, remote asset tracking, and environmental monitoring. Low power consumption. LoRa is designed to be extremely energy efficient. Devices can transmit data using minimal power, allowing them to operate for years on a single battery, depending on usage. This is crucial for battery-powered sensors in remote locations where frequent replacements are impractical or costly. Scalability. LoRa networks can easily accommodate a large number of devices, making them suitable for large-scale deployments. Additionally, the technology allows for seamless integration of new devices without impacting existing connections. This scalability is essential for applications like smart cities, where thousands of sensors might be monitoring various aspects of the urban environment. Cost effectiveness. The overall cost of implementing LoRa is relatively low, particularly compared to alternatives like cellular networks. The simple infrastructure requirements, low-power devices, and free LoRaWAN specifications contribute to its cost effectiveness. This makes it attractive for various applications where affordability is a key concern. Standardization. LoRa follows the LoRaWAN protocol, ensuring interoperability between devices and networks from different vendors. This standardization simplifies development and deployment, allowing users to choose solutions from various providers without concerns about compatibility issues. Security. LoRa incorporates robust security features, including end-to-end encryption and authentication mechanisms, to protect data privacy and integrity. This is crucial for ensuring the reliability and security of sensitive data transmitted over the network. Two-way communication. Unlike some other low-power communication protocols, LoRa enables bidirectional communication. This means devices can not only send data, but also receive commands or configuration updates from a central system or other devices. This two-way communication capability expands the functionality and application possibilities of LoRa networks. Geolocation capabilities. While not a core feature of the LoRa registered trademark protocol itself, some LoRa devices can leverage additional technologies like GPS or triangulation to provide location information. This adds valuable context to sensor data, enabling applications like asset tracking or environmental monitoring to pinpoint the exact location of data points. These 8 key features make LoRa a versatile and powerful technology for various IoT applications. Its ability to overcome traditional limitations of range, power consumption, and cost creates a unique value proposition for connecting devices and building robust, efficient, and scalable IoT solutions. While directly connecting to a full LoRaWAN network requires an internet connection for the network server, there are options for hobbyists to experiment with LoRa communication. Peer-to-peer communication. This approach allows 2 LoRa devices to communicate directly, exchanging data within a limited range, around 1 to 3 kilometers. It's suitable for simple projects like remote control or data sharing between nearby devices. Required hardware? 2 LoRa modules, antennas and batteries. Software setup? Install libraries like Arduino LoRa or Radiohead on your development board. Write code to configure the LoRa modules for peer-to-peer communication, defining frequencies, data rates, and message formats. You can set up a local server on a Raspberry Pi or similar single-board computer to receive and store data from LoRa devices. This offers basic functionalities like data logging and visualization, but won't provide internet connectivity or advanced features like device management. Some community-driven networks like the Things Network offer limited coverage in certain areas where internet access might be restricted. These networks operate on a best effort basis and might not offer guaranteed connectivity. In this world of uncertainty, LoRa and LoRaWAN offer a ray of hope. Picture a scenario where traditional communication channels are disrupted, where the world as we know it has been turned on its head. In such a post-apocalyptic landscape, LoRa and LoRaWAN hold the potential to create a decentralized, long-range communication network that can withstand major disruptions. Imagine a world where the grid is down, where power is a scarce resource. LoRa and LoRaWAN's low power consumption comes into play here, providing a lifeline in a resource-limited scenario. Their ability to function on minimal energy makes them an indispensable tool for maintaining communication when everything else fails. But it's not just about survival. LoRa and LoRaWAN could also be the building blocks of a new world order, a society that rises from the ashes of catastrophe. Their potential to connect devices over long distances, even in challenging conditions, could be the foundation of a resilient, decentralized network that fosters communication, cooperation, and ultimately, reconstruction. In this brave new world, LoRa and LoRaWAN could be the glue that holds society together, the invisible threads that connect us all. They could be our guides in the darkness, our beacon of hope in a world turned upside down. In the face of potential calamity, LoRa and LoRaWAN stand as pillars of resilience, connecting us even in the darkest hours. Thanks for watching. Do like this video and subscribe to SciSips for more.